Hello everyone, my name is Zhida Zhang from the University of Macao. It is a great pleasure to be here at ISARC 2025. Today I will share our study on interface management of robots in construction, a case study of an overhead drilling robot. We will talk about what kinds of challenges we face when integrating robots into real construction sites and how we can deal with them. In the following presentation, I will share our research from 6 perspectives. Firstly, let's talk about the research background. As we know, construction projects often suffer from low productivity, safety risks, and quality issues. Robotics can help improve all of that, but in reality, construction robots adoption is still quite limited. What's the reason? One major reason is that when robots are introduced into construction sites, they inevitably interact with traditional building processes, and these interactions create new and complex interface issues. We can define an interface as any meeting point of two entities, products, people, or processes. And in this study, interfaces are categorized into 3 types: physical interfaces, contractual interfaces, and organizational interfaces. That's the starting point of our study. So what are we aiming to do? First, we want to identify the key potential challenges that arise when robots meet traditional construction process. Second, we examine the causes of those problems. And third, we want to propose practical strategies to better manage these interfaces. Now for the methodology part. We use the PCO framework, physical, contractual, organizational as our guide. First, we did a literature review on major databases, and then we conducted a case study with site visits, document analysis, and 7 semi-structured interviews. We also coded the data in vivo software to find key themes. And finally, we held a focus group to validate and refine our findings. The case we studied was a large-scale residential project in Macao. It followed an EPC contract model, and the mechanical, electrical, and pumping, or MEP work, was handled by various subcontractors. To improve efficiency and coordination, the goal was to use a drilling robot to integrate all the MEP drilling tasks. This robot is semi-automatic, guided by a total station, and reads AutoCAD or Revit data. It only takes about an hour of training to start using, which makes it fairly easy to deploy on-site. Now let's look at our research results. Physical interfaces mainly arise between robots and 3 elements: workers and operators, site environment, and build structure. For example, if an operator accidentally touches the total station used for positioning during the construction, it can lead to drilling errors. Meanwhile, the complex and dynamic nature of construction sites can also reduce the operational efficiency of the robots. In addition, robots may cause damage to completed structures, such as rebar and finished paintwork. Contractual interfaces mainly involve 2 aspects. First is the reassignment of work packages. Since the pilot project didn't have an integrated MEP supplier, tasks were handled by various subcontractors. However, as the robot took over the whole drilling process, it led to unclear contractual responsibilities. And the second issue involves unclear liability attribution. When robots make mistakes, like causing delays, leaving rework, or some additional measures, it becomes hard to know whether it is the fault of the technology, the operator, or the project team. These contractual interface problems are often caused by immutual business models and inadequate construction management. On the organizational level, the implementation of the drilling robot on construction sites involves multiple stakeholders, so things get even more complex. This slide summarizes key interface challenges observed during the robot adoption. We have grouped them into project, government, and industry levels, highlighting issues such as communication and coordination problems between different organizations, lack of clear standards and regulations, and a weak culture of innovation. So how do we manage these interfaces? We suggest three types of strategies. First, technical strategies. We can make robots more adaptable to complex environments, more flexible in handling on-site changes, and easier for workers to use. Second, contractual strategies. By adjusting contract terms, we can make responsibilities clearer and reduce disputes. Also, new business models can help better define collaboration and manage risks. Third, organizational strategies. This includes improving communication between teams, encourage support from government, and build a stronger innovation culture. Next, I would like to show some key findings from our research. Here we introduce a framework to manage interface problems for construction robots. It focuses on three parts: physical, contractual, and organizational, so we called it PCO framework. The PCO framework summarizes the components of various interface issues and their corresponding management strategies, while also revealing the interrelations and mutual influences among these issues within the construction workflows. This slide goes deeper into the main interface problems we face. Among the three physical, contractual, and organizational interfaces, contractual interface problems are the most important, as robotic integration often requires redistributing work packages and deciding who should be responsible when problems arise, which greatly affects how the project is organized and carried out. What's more, these issues don't exist separately. For example, if a robot has low adaptability, it might require changes to the contract. If the contract is unclear, that could cause team coordination problems. And if the management is weak, it can make both technical and contract-related problems even worse. So overall, the contractual interface plays a central role. It largely decides whether robots can truly fit into construction workflows and drive industry progress. In addition, these three areas are closely linked, and we need to consider them together when managing robot interfaces. So in conclusion, we propose the PCO interface framework to support the integration of robots into construction workflows. And we find that contractual problems are key barriers for robot adoption, and suggested new business models and collaboration strategies to deal with them. This research also builds a theoretical foundation for understanding complex interfaces and provides insights that can support wider adoption of construction robots. In the future, we plan to refine this framework through more case studies and on-site observations, so it can offer more practical guidance for the robot application. That's all from our side, and we sincerely thank the University of Macao for their funding support and China Construction Engineering Company for their help with the case study. Thanks for the listening, and I look forward to your thoughts and questions.